Well, hello and welcome to another Dev Nation. We have an exciting topic for you guys today. I know all developers at this point, all architects are about Linux as their deployment system. Linux is the way they put their services out there live into the world. And we're going to talk about the next generation of Linux. We're going to talk about that right now. Do keep in mind, we're going to take your questions and chat information into that chat tab. I will be trying to pick up questions and throw them at Max later into the session. There's a lot of people on the line today. You can kind of see our numbers will be building. A lot of people will be entering the chat, so just keep that in mind. It'll be kind of noisy, I suspect, but we have a really great session for you. So let me introduce Max Burgerhout. Yes, I think I got it right that time. He's coming to us live from the Netherlands, and so he's going to be drilling down and showing us a lot of great demonstrations, plus he has a lot of links that I'll be providing in the chat as we go. So just keep in mind the chat tab will be your friend. And remember, if you can't hear or can't see, which you can't hear or can't see, refresh your browser. It's 99% of the time that solves the problem. All right, well, let's get started. Max?
Thank you, Burr. So let me switch to my presentation real quick. Or maybe just doing a little intro about myself. My name is Max Burgerhout. I work as a solutions architect for Red Hat in the Benelux region. I specialize in the Red Hat platform and cloud portfolio. And in that work, I talk to a lot of people in operations as well as people in development teams and talk about our products, talk about RHEL. And the last couple of months, I've been talking about RHEL 8 a lot, RHEL 8 beta, and that is what we'll be doing today. I'll show you around the new version of RHEL that we've been building and show you around. And so don't be afraid to ask any questions in the chat box. I'll try to answer later on as many as I can. So let's switch over to the presentation screen there. There we go. So I hope you guys can see this. Let me check. Yeah, you guys can see this. So we've had this bit. I also do a lot of Twittering. So if you want to follow me, go to @MaximBurghout at @MaximBurghout on Twitter, and you can follow me there. Tweet about a lot of Red Hat related stuff. I also do a lot of stuff on YouTube on a channel called 100 Things to Do with Red Hat Management Products, and you'll probably forget that, so you can go to bit.ly/100 Things Red Hat as well. And I have a couple pretty cool videos about Ansible and all that kind of stuff over there if you want to hear more. So in order for me to understand my audience a little bit better, I would appreciate it if you could go to bit.ly/DNLpoll. That's bit.ly/DNLpoll. And you should see this specific screen there. Just pick a couple of languages that you're interested in using on RHEL 8, and maybe some languages that you're already using on RHEL 6 or on RHEL 7, and I'll try to tailor my demos based on the results of this poll later on. Now, while you're doing that, I have to show you this. What I'm going to talk about is beta software. That means that not everything that is part of my demos might not or will not end up that way in the final product. Some things might change before general availability. Some things might end up to be tech preview. Some things might be dropped completely. That is all still, undergoing debate until the very final moments where we decide what is in J and what is not. So please don't try to read anything between the lines. Don't assume any software versions you see scrolling across my screen are going to be available in that specific exact version, because it might not be so. Having said that, here's what I want to talk about today. I want to talk about a very cool new feature called App Streams, which is part of RHEL 8, that allows us to give you faster versions, or basically give you access to new versions of programming languages along the lifecycle of RHEL 8 all the time, multiple versions in parallel as well. I'm going to show you how to build a quick LAMP stack with what is available in RHEL 8 in terms of software. We'll look at what else is available in App Streams, because LAMP will be Linux, obviously, Apache, MySQL, PHP. What else is in App Streams? We're going to look at how to build containers with RHEL 8, but we're going to start off with something that is pretty cool and pretty new in RHEL 8. We've had it in RHEL 7 as well, to be honest, but RHEL 8 is offering a lot more functionality in this thing called Web Console and Image Builder. So let me switch over to here. This is, let me maximize that as well. This is the Web Console login screen. I'm going to log into this with my root credentials because I'm lazy, but you can use non-privileged accounts as well if you want to. And this gives me a web-based UI to control my system with. So you don't have to learn all those command line tools. You can just log into the website and manage many, many parts of your system. You can still do command line. Obviously, it won't interfere with each other, but this makes it a little bit easier. So things you can do here, for example, you can apply updates. You don't have to go into, you don't have to log in over SSH and do yum commands. You can just go here and apply updates. It's simple. You can join a domain. You can view the system logs. And Web Console is installed by default on every new installation of RHEL 8. And you don't, the only thing you have to do is enable it, so it will be there. You can go through all of the logs and filter the logs by date. You can filter the logs by severity. So if you have an application that logs to the normal syslog, it's very easy to just go to this website and read through all of the potential error messages or whatever. You can configure storage. So maybe you have an operations team that presents a new disk to your test or development environment. You can go into the Web Console and configure that piece of storage yourself. It's pretty easy to do. You could go into the networking tab and you can get metrics about the performance of your network interface. You can get networking logs. You can configure bonding or teaming or bridge or whatever. And you can even manually or automatically, I should say, configure your firewall. Just click this link over here, click add services. And you can, for example, let's say we want to build a web server here. So we go search for HTTP and we can click there and add service. I'm not going to do that now because this specific machine does something else, but I can just open up firewall ports very easily through this UI here. I'm going to use 3 systems in my demo that I'll talk about in a second, and we'll be able to add these systems individually to the dashboard here so we can get some metrics about the systems that are running my application. So maybe I have a database server and 2 web servers and a load balancer. So I want to keep track of the performance of those systems, and I can do that in a single UI that will show you the performance of all of those individual VMs in terms of CPU, in terms of memory, in terms of network performance, in terms of disk throughput. And I can keep track of how that is working from the Web Console in RHEL 8. So that's, I think that would be pretty useful if you're trying to debug performance of an application. Now, one other thing I want to show is called Image Builder. Image Builder is a really cool new feature in RHEL 8, and it allows you to build images for various private and public cloud platforms right from the Web Console in RHEL 8. So basically what you do is you go to the Image Builder tab here, go to Create Blueprint, give it a name, let's call it DNL Demo. And I can just add RPMs to this. I can just say, give me Git, because we're developers, right, today. So we just give me Git. There we go. And I can install, where are we? We can install Git. Now I can commit this specific package that I've added to this. So the blueprint will now be saved with the addition of Git here on top of what is absolutely minimal for an operating system to run. There we go. And from there, I can go create an image. I can click Create Image, and I can create an AMI, QCOW image for OpenStack, a generic QCOW image, an Azure VHD, or VMware VMDK. I can just click this, click Create, and then I can wait a couple of minutes, and it will spit out a file for me to download and push into, I don't know, private or public cloud. So that's pretty useful. And one of the use cases for that is, for example, to build images for a web server, images for a load balancer, images for a database, and use these as the basis for your application deployment. And by using these, you can speed up application bootstrapping by a large margin. And I've been talking to customers that tell me that building a database from scratch based on an empty image can easily take them 10, 20, 30 minutes because of the software installations they need to do. Well, no more, because we can simply create and push an image that contains all of the software already from onto that private or public cloud platform. Now, as an example, I have empty base image here. Empty base image has a couple of components selected. So I have Cockpit, which is the community name for what we have here in the Web Console. We have Git, we have Midnight Commander, because also I do forget commands as well. We have some other RPMs that I wanted to have installed in this image. So if you want to add custom RPMs to this, that works as well. And then I've created an image. It's a QCOW image, has been built. I built this last Wednesday, and I can just download it from here and then push it onto my RHEL cluster and boot VMs from it. And that is exactly what I have done with the 3 VMs that I mentioned earlier, the RHEL 8 beta DNL 01, 02, and 03. They're based on that image I built in Image Builder. So I think that would be pretty interesting to take a look at. Now, I've only showed you how to do RPMs, create an image based on RPMs. But if you would go to the terminal over here on the system that I'm building these images on, I can actually see the configuration of these images as they're stored in a text configuration file. So the empty base image looks like this. Come on. Has a name and description, version number, and it has a list of packages. As you saw already in the other screen, they're added when this image is built. And then I edit this manually just by editing this file to create a root user with a very simple password that you should not use in production, obviously. And I'm adding an SSH key. So when I built this specific image, I can just upload it to a private or public cloud or to a VMware cluster, and I can, from there on, use Ansible to do the rest of the configuration, because I already have a user that has a known password and a known SSH key. So that should be interesting. Let's move on to some programming environments. So let's take a different system for this. Let's use the 01. So I'm going to assume that a lot of you are interested in Java. So I'll start there, because Java is also a little different. Java is not an app stream per se. Let me check. This is readable, right? I hope so, at least. It should be. We ship in the RHEL 8 beta, we ship both Java 8 and Java 11. So I can just go do yum install Java 1.8.0-OpenJDK devel. And this will install Java 8. So this is just the way it works on RHEL 7 and RHEL 6. It's the exact same thing. Notice that I'm not using DNF. DNF, you could probably change that acronym to mean do not follow or something like that. It's just consider it to be yum4. All of your muscle memory that you know from using yum, it's still there, and you can use yum as the command line name of the command utility as well. So now I have installed Java. I can just go Java version. I have Java 1.8. I have the Java compiler here as well. So that's both there. I can also install Java 11. That's not much different from Java 8. There we go. Install Java 11. Now I have two versions of Java on my system, and the way we switch between the two versions of Java is actually quite the same as it would be on RHEL 6 and 7. It's the alternative system, and I'll show that in a second. Now we ship both 8 and 11 versions of Java. Those are the upstream long-term support versions. We do not recommend ship or support Java 9 or 10. You can read more about that on the customer portal, because they are not long-term support. I think Java 1.8 and Java 11 have end-of-life dates somewhere halfway to 2020s, so you should be fine for a while. Let's go do alternatives list here for a bit, so we can see that we have Java linking now, pointing to Java 1.8. Let's switch that around. Let's do config. Come on, config Java. Let's point it to Java 11. Let's do the same thing for the compiler. Now go to my demos directory and compile this little Java program I have there, and run it, and it should say hello RHEL 8. So we have Java 11 and Java 8 available on RHEL 8 beta. Okay, so that was one. Now I want to see what the poll looks like. So let's switch over to the poll. Hoping I'm picking the right screen here. So let's pick this one. Okay. So where are we at? What's interesting? Python is interesting for people, and that's good to know, because Python is actually a little different from the other app streams as well. And shell. I'm not going to do shell. That's more here as a bit of a just to make that poll complete. So let's look at Python for a bit, because Python is interesting in terms of RHEL 8. So normally on basically every Linux system, you can go Python and you drop into the interactive Python shell, but not on RHEL 8. RHEL 8 does not have a version of Python that is available in the standard location that you would expect it at. Let me check my notes real quick. I'm not skipping over something, because I probably am. Oh, anyway, where's Python? Oh, there we are. So that's not there. We do have a hidden version of Python over here. That is what we use for things like Ansible and Stratus and Anaconda and things like that. But if you want to use your own version of Python for example, for Django, if you want to write a Django application, you probably want to use the Python that we ship in the AppStreams repository. Now, if you check the way we ship RHEL, no, that's not a command. You can see that we actually only have 2 repositories for RHEL, so that's a lot easier than it used to be. We have base OS, which is everything that's has something to do with the actual operating system, and we have the AppStream repository, which is where all of my programming environments live. If I want to take a look at all of the app streams that are available to my system, I go yum module list, and it will spit out a whole list of all of the modules that are available to my system. And here you can see that we ship both Python 2.7 and Python 3.6 as an app stream. We can install them both, to be honest. So we can do yum yes install module Python 2.7, and we get Python 2.7 installed. Now I'm really happy. Oh, wait, no. It's correct. When you do demos and something goes wrong, you always get almost a little heart attack. Everything turns out to be fine. So we get Python 2 running here. Python 2 got installed. We installed Python 3.6 as well. So this will give me Python 2 and Python 3 binaries. So I now have Python 2, right? Python 2.7, Python 3, Python 3.6.8. That's fine, but I still do not have a Python binary. So if you want to do, basically just install Django from its Git repository, it's probably going to refer to the Python binary. If you want to set up either Python 2 or Python 3 as the Python binary in your normal path, just run alternatives config Python and select Python 3. And Python 3 it's really cool. It's going to enable you to run Django 2 and up, which is something you couldn't do with Python 2 as far as I know. So Python still there, and just a little bit more flexible. So these app streams will allow us to ship more modern, more modern programming languages and switch them out a little faster than we were able to with RHEL 6 and 7. And they also allow us to basically start shipping new major versions of programming languages halfway along the life cycle. RHEL 8, for example, we don't have to wait for RHEL 9. So that's pretty cool. So let's see what other languages you guys were interested in. So we have Java, Python, we talked about Python. We have PHP. So I'm not a Perl guy, so this is the one thing I don't have a demo for. So I'm going to do PHP, right? Because I want to show you how to build a LAMP stack anyway, because that is all built on app streams in RHEL 8. So let's go look at PHP. Let's look at what versions of PHP we have available as an app stream on RHEL 8. We actually have 2. You have PHP 7.1 and PHP 7.2. Now don't expect these to both ship for GA. That's just my personal expectation. It doesn't really make sense to have these 2 ship for GA as well, but it makes for a nice demo, so I'm happy they're here. We have 7.1 and 7.2. The 7.2 has a little d between square brackets there, which means it's the default version that you will install if you install Python. If you install PHP, you will get PHP 7.2. And then you get the common profile. Now, what a profile is probably easiest explained based on a database. So we have Postgres here. Postgres 10 is the default. We also ship 9.6. And then we have a client and a server profile. The server profile is the default. If I run yum module install PostgreSQL, I would get version 10 and the server. If I want to install only the client, which is the other profile, I have to explicitly tell Yum to do that. So that's probably explains what a profile is. So in order to be able to show you how to upgrade a module, I'm going to force it to install PHP 7.1 for now, PHP 7.1, and then actually install it. Yes, you see that we also enable modules, app streams for Apache, HTTPD, and Nginx. So we also ship Nginx as part of an app stream. So if you don't want to use Apache, Nginx is there for you. Now let's install PHP. I shouldn't have done the -y. Scroll back now to show this. Come on, stop. Good. So as you can see, we are installing PHP. We're also installing Apache. We have some weak dependencies here that are installed by default, but you don't have to necessarily. That's a new feature in Yum 4. And I have PHP 7.1. So what we now need to do is make sure we enable the actual web server, HTTPD, and copy over the index file to the web server directly like that. And then we need to open up the firewall. So let's open the firewall through what we had earlier in the web console. So let's go over here. Let's click this. Let's go add services. Let's go HTTP click there, add service, and there we go. We now have web traffic over port 80. We can go here again. So I can, let's open up a new page. Let's go RHEL 8. There we go. So the only thing in the index file was PHP info, and you can see here now that version 7.1 is running on this system. This is not really spectacular, I know that, PHP info. Let's go back here and upgrade this to PHP 7.2. So it's yum module install PHP 7.2. So I'm specifying the version of the app stream I want to use. And just wait a couple of minutes for this to finish. There we go. We go to restart HTTP. And as you can see, we've switched from one app stream to another, from 7.1 to 7.2. And we've installed PHP 7.2. So if I go back to my PHP info file here, take a look at the version number as I refresh this, bam, and we're on 7.2. Now, probably you don't want to do this in production, obviously. You only want to do this in test and dev systems, but it makes for a fairly easy way to upgrade from one version to another. Modules will not migrate your data, so keep that in mind. If you do this from Postgres 9 to Postgres 10, which we both ship in RHEL 8 as a beta, the Postgres 10 is going to tell you, no. You have to export and import your data because the data format changed. So modules will not help you there, but they will help you with making that software available for you, which is half of the job, right? So you don't have to go to all kinds of third-party websites anymore to get your hands on a new version of PHP or Python or whatever. So now we have Apache and we have PHP, we have them both running. To build the proper LAMP stack, we need a database, right? So let's go back to my list of app streams and check what kind of databases we have available in RHEL 8. Bam, there we go. So we have, from top to bottom, we have MariaDB, which is what I'm going to use later on. We have MySQL, whatever you want to call it, version 8. We have versions 10 and 9.6 of Postgres. Again, do not assume this will all end up in the GA version of the product, but I'm just showing you what we have in the beta. And we have two versions of Redis, versions 4 and 5. Now, for my demo, I'm just going to use MariaDB because that is personally what I'm most familiar with. So I'm going to go yum install Maria module install MariaDB. And if you look at how this is formulated, this is going to give me version 10.3, and it's going to give me the server because that's the default. So let's go there, install. And there we go. So you see we're enabling some modules, MariaDB, obviously some Perl stuff, installing my MariaDB server profile, installing some packages, some dependencies, and some weak dependencies because I'm not explicitly told it not to. And there we go. And yep, go. So if we go here, you can see that, oh, darn it. Some of these RPMs came from the base OS repositories, and some came from the AppStream repositories. So now I have my database installed. As a good little boy, I should now start it up. Now MariaDB. There we go. So now start it, and as an even better little boy, I should run the MySQL installation script to make sure that my password is set and all the weird stuff has been removed from the database. So there we go. Database has been set up, and now I need some little bit of glue between my SQL or MariaDB and PHP. So we install PHP MySQL ND, which is a little module, PHP module to talk to MariaDB. And now we restart the database, the web server again. There we go. And copy a little demo script to that location. Yep, no. And then we go back to this page, we go add minor. As you, this is just, I don't know if you guys know this this specific script, but it's a PHP script that you can use to do database administration, a little bit like PHP MyAdmin, but I think it can do all kinds of different databases. And I can log into my local database. I can create a database called DevNation, and there we go. So that all works perfectly, and that's pretty nice. It's the way LAMP works on RHEL 8. Now, I've shown you that we've shipped with MariaDB, MySQL, Postgres, and Redis. We are not shipping Mongo anymore. If you want to learn more about why that is, it's a legal reason, has to do with a new license for Mongo. It's in the RHEL 8 release notes, and I think Burke can probably link that in the checkbox at this point. I'm not going to install Postgres because I think that probably take a little bit too much time. So let's do one more language just for fun and giggles. What else did you guys think was interesting? Let's do, I think I did Java, right? So let's do, I don't think Rust is getting enough love. It's kind of disappointing. Let's do Go. Let's go weird and let's do Go. So in RHEL 8, let's take a different machine for this. In RHEL 8, we actually ship, bam, RHEL 8, so it's the second VM. We actually ship Golang and Rust and Node and all that stuff in app streams as well. So if you check that module list, app stream list again real quick, you can see we have Rust toolset. That's kind of my thing. Scala, we have Varnish as well in here. We have Node, 2 versions of Node. We have, where's Golang? We have Golang. We have LLVM. So we have a whole lot of different languages you can play around with. But for now, we're just doing Go. So let's go yum yes install Go toolset. So no more playing around with that. Get that supported and shipped from Red Hat on your system. There's Go. So 1, 2, 3. So I have a little demo hello world file for this as well. So it shouldn't take too long to demo this. And then we'll take a brief look at how containers work on RHEL 8. And I think we need to call it a day at that point. Come on. It's a huge RPM. Pick the wrong demo to do, I see. I think the Rust one is probably even bigger. Okay, come on. Almost there. Okay, there we are. So now I have Go. So what I can do now is go into the demos directory that also lives on this machine. I have a little Go program called hello world.go. It's, if you write Go, it's pretty simple. It's just package main, import format, and then it says hello world, hello from Go toolset RHEL 8. So we can just go build hello world.go, and then we go into binary, and that's it. So we have Go available on your system, just as Rust, just as Node, just as LLVM, everything is just there. So let's take a brief final look at the way containers work. If you've paid attention over the past couple of years, you know that we've built together with the community a couple of purpose-built tools, Scopio, Builder, and Podman to manage your containers with and build your containers with, basically along the Unix philosophy of do one thing and do it well. Don't have a daemon running if you don't have to. And because it also aligns nicely with what the upstream communities in OpenShift and OKD are doing with Cryo. I won't go into a lot of detail about the backgrounds there, but just know that we have Podman available on RHEL 8. There it is. I installed this because it takes forever to install because there's an SE Linux add-on it needs to compile at installation time. I can Podman run it registry.access.redhat.com. We have RHEL 8 container images available for you if you want to play around with them. I suggest you do. And just say hello DevNation RHEL 8 data is awesome. And I should be able to run this. I will pull that RHEL 8 beta image from the Red Hat registry and run that echo command in it. Now, we can also do that with a RHEL 7 image. They should be compatible with each other in a RHEL 8 kernel space and a RHEL 7 userland. We pay a lot of attention to making sure that works. Just wait for 1 or 2 seconds to, there we are. Hello DevNation RHEL 8 beta is awesome. So there we have Podman running. Now, Podman can by itself build, let's go into the container directory there. Podman can build containers based on a Docker file. So if you want to build, what was that again? If you want to, basically you could symlink Podman to Docker and would, it's command line compatible. So we can keep Podman, let's forget what this is, build, tag it as DNL demo, and build it. So then we'll just build the Docker file that's listed there. Pull down the RHEL 8 beta image. We already got that, and we can now see what images we have built. And we can actually run that thing that I built a couple of seconds ago. It should output that exact thing. So Podman can help you build images pretty quickly and pretty easily. Builder can actually help you do that in a more flexible way without having to rely on a Docker file. Builder allows you to basically mount a virtual file system on your system and then install your software with yum or just by copying files into that directory. And you can do that with any kind of scripting you want. It will give you one layer of container image, and you can do that very easily as well. There are great tutorials about that from Dan Walsh. But I think I have to call it a day at this point because we're 28 minutes in. So I'm going to switch back over to the in Expo screen. I'm going to stop my screen sharing. And maybe we can do a little bit of questions and answers.
And we have a lot of different questions. Let's try to hit a couple. One that was very obvious is the web console looks awesome, but what if I have 1,000 or 1,300 servers? Was Carl's question. 1,300 servers to manage. What would be the strategy for managing a massive number of servers?
Yeah, that would be Ansible, right? If I could theoretically, I think I showed that I could theoretically add all of those systems to the web console and manage them one by one. That's not what you want to do if you have 1,300 servers. So that's where Ansible comes in. You can write a nice playbook. The playbook can touch as many servers as you want, and then your life as a sysadmin or as a developer, no matter what, becomes a lot easier. So Ansible is your friend there.
And satellite, I think, as well. Is that another key ingredient from this architecture?
Oh yeah, obviously, yeah. So I'm trying to figure out which sound I should mute. Sorry. Yeah, satellite should definitely play a role in that as well. I actually made sure my satellite worked with these demo VMs earlier on to make sure that all of the software I wanted to install was lightning fast. Satellite makes it easier for you to make sure that you can have a fixed patch cycle. So if you don't want to just talk about configuration management, which I was before, and you want to talk about patching and doing software releases based on RPMs, yes, satellite is definitely where you want to go. And for VM provisioning as well, it's awesome. Yeah.
Okay, and then we're kind of running out of time, but I want to make sure we talk about migration. That came up as a question multiple times. People were like, "Hey, I've got RHEL 7 servers. How do I upgrade, migrate to RHEL 8?" What would you say the strategy should be? What should people be thinking about as it means preparing for their migration, their upgrade?
So, let me see. Yeah. You can do various things. So we do try to provide an actual upgrade path, as far as I know, between RHEL 7 and RHEL 8. So you can actually do the in-place upgrade. My recommendation based on experience would be that you could do that, but if you're moving towards a more, cattle approach of all of your systems, have cloud image and all that kind of stuff, you probably have your Ansible playbooks ready. You could redeploy your system in a breeze. But if you can't, that upgrade path is brilliant, and it should really take a lot of the pain off moving between different RHEL versions.
Okay, that was a key question that people were very focused on.
Okay.
There's a bunch of other things too that were interesting. One was, can I build images without needing to be root? Can I make that a service that my users can go craft their own images without needing to be root? Has anyone thought about that from a RHEL 8 standpoint?
So if I'm not mistaken, I actually did that for these images because you always try to, when you do a demo, you try to be you try to take every possible opportunity for a failure out of the workflow. So I logged in with root, but I can log into that web console with my normal user, and I can just build those images with my normal user account. It's actually not a problem. You could do a build farm for each and every development team could have their own web console system and build their own images and push them into a cloud. Shouldn't be a problem.
Okay. Oh, very good. And that makes sense to me too. And then one thing I want to just double click on, and then unfortunately we're out of time, and I apologize that from a question standpoint. But what about my software collections, Ansible app streams? Does that replace my software collections? Just talk about that one more time because I did see that question come up several times.
Yeah, so AppStream solved a problem. So I'm not a product manager. We have a product manager here in the room that would be very welcome for this question. But to my understanding, AppStream solved the problem, but it also didn't solve some other problems. And with AppStreams, what we can actually do is put those binaries in the expected places on your systems. Like it's like user bin Python. It's not in some path in opt or whatever, and that makes it more. It makes it easier to develop for those systems and bring those new versions into RHEL in the locations that they're expected to be. that is, I'm not the person to tell you whether or not app streams are completely replacing software collections in the end. That's up for product management to say, I think.
Okay. And that's a fair point. And unfortunately, we are out of time. We're over our allotted time for running these webcasts. Thank you guys all so much for your questions. Feel free. You guys all have my email address. Send the right person to answer them. And but otherwise, we had a lot of engagement, lots of questions, lots of ideas. The demos were awesome, by the way. I think you did an awesome job. So thank you so much for that. And the presentation was fantastic.
You're welcome. What I can do, if I'll just drop my Twitter handle again in the chat box. So if you want to ask questions that are for the benefit of the whole world, just ask them there, and I'll try to answer them. And yeah, if not, my email address is pretty simple as well. So let's drop that in there. Yeah.
All right. And yeah, and I see the Twitter link there too. All right. Well, thank you so much for your time today. Thank you all for attending. Max, awesome job. And hopefully we'll get a lot of questions in the back channel and over Twitter and email. And then otherwise, please go download that RHEL 8. We gave you the download link, and make sure to check out the cheat sheet, and make sure to check out the other resources we added to the chat. Thank you so much, and have a great day.